This is going to be one of two videos talking about two major ways that you can use to start creating sheet metal parts within SolidWorks. And the first thing I'm going to talk about in both of the videos is in order to actually get our sheet metal menu. So I've got the option of finding the tab version. So tabs are all of the pieces that are going to show up in this ribbon up here. So things like this, or I could find it in toolbars. There are a lot more toolbars, and they're a lot more specific to individual commands, but I could add a toolbar if I wanted to. I like to use the ribbon, so we're going to go ahead and add the sheet metal to the ribbon. And our entire talk today is going to be focused on just this one little command, which is converting to sheet metal. So what the converting to sheet metal is going to do is it's going to take my part here that exists completely as an extrusion. So you can see it's a boss extrude. I did set it to be steel, but this does not actually know that it is sheet metal. And this steel's actually not got any sheet metal properties set up with it. But I'm going to take this and I'm going to create it into an actual piece of sheet metal here. So with this, the first thing that's going to show up when I click the convert to sheet metal are a bunch of pieces right here. And we're going to get into these guys in a second. But the important ones are this guy right here, which is going to select our primary face, which is becoming sheet metal, and everything else kind of comes off of that. We have our thickness of our sheet metal here, which I have set to 0.019, which is the thickness of 26 gauge galvanized steel sheets. And then at the bottom here, I have my default bend radius for if I try to create bends in the sheet metal. You can set these individually, or there are actually two pieces up top here that I'm going to kind of click through here that we can work with. So this first one up top, that is going through and that is adding a set of properties, so it would automatically designate these guys down here based off of the material that I have selected and set for my sheet metal type material. And then this guy here that I was just scrolling through a second ago is using my gauge table. So there are a bunch of gauge tables which are pieces and settings set up in SolidWorks that have, again, a bunch of these settings in them. What I find for both of these is what's available between versions can vary, and values can vary a little bit if you're unlucky. And seeing as I end up having a lot of conversions for class, we're going to, at least in my class, be working mostly with just setting our sheet metal parameters ourselves. We can kind of look up and we can choose based off of what we think is best. But important to know that those are there. With that, getting into actually creating our part, again, I'm selecting that face like I did before. Any second now I'm selecting the face. There we go. And that is what I'm saying I'm going to be turning into sheet metal. So I hit the check and it is now a sheet metal piece. I have all of my sheet metal properties in my document right there. And if I wanted to go and change that convert solid into sheet metal, basically that is where I can go in order to get back into this command. That will reopen that command piece. So I know normally when we use one of these big commands in order to do something, it only creates one. In the case of sheet metal, it's actually going to create three. We're going to talk about that last one a bit later when it makes a little bit more sense. So that is creating our piece of sheet metal. Now, with this, we could actually have multiple of these convert sheet metals in the same file. Just like when we did our extrude, we can extrude and merge, or we could extrude and not merge, in which case, if we extrude and not merge, we end up with multiple bodies. So I could have multiple pieces of sheet metal in the same part file. And I could also have some pieces that are sheet metal and some are not. So I went in and I clicked this keep body function right there. This is useful if you want to create multiple, convert multiple aspects of your model into sheet metal, because if you don't keep the body, Once you've converted what you want into sheet metal, the rest of it disappears. But I'm mostly just using this to kind of point out here that we had a set thickness. So this part had a thickness that I set, and I typed in some number, and that is what my extrusion was. However, my sheet metal is now actually only this thick. That is, circle's a little off there. There's my sheet metal piece here. This thickness piece that's basically the thickness of my pen here is my sheet metal thickness, versus the original part that I converted to sheet metal was much larger. And to prove that, I've created two bodies. We're seeing that there's two bodies right here. Same place we found multiple bodies before, except now we have sheet metal versus non-sheet metal. And the other thing I can do here is I can change how much is suppressed. So I'm going to go ahead and remove the body. And what I'll do is go back and forth, and you can see that this thickness was changing as I did that. Great time to circle. Anyways, with that, seeing as we know that the thickness doesn't matter, we could actually make this base extrusion whatever we want it to be. So I'm going to make it way thicker than any sheet metal is ever going to be. 4-inch thick sheet metal, unlikely to be something you're working with very often. And I can go back in and I can convert to sheet metal just like I did before. But now I'm going to talk about this extra piece here. And this extra piece is creating these bend edges. So what these bend edges are is I am defining that if this is my base piece, that is what I selected up here, which is about to be important. I know I said I'd get back to it, and we're still going to get back to it. Everything that else that exists, I can have bend from that. So I am saying that this is my bend edge. This face and this face are connected, and they are connected by a bend of my material that went through here. And I'm also saying that on this, by selecting this edge, this face and this face are connected by a bend. And that means that the sheet metal flips up this way and the sheet metal flips down this way. So up like so, over like so. And in order for that to be true, this piece right here needs to be a gap, meaning that this piece and this piece can't be the same. They can't be connected right here. There can't be a physical connection there because the sheet metal couldn't physically be made like that. There's no way to bend this guy over like so and this guy over like so and have these already connected in some way and bent over like that. So let's get rid of all that drawing. And you can actually see on here that it's drawing this appropriately. You're seeing the yellow is my preview. So I'm seeing that yellow exists, but on either side of this piece, I'm seeing no yellow. I'm seeing that actual gap going on in there. And that is what we want to look at here. We're going to go through and we're going to select a bunch of edges here. And those edges are the pieces that I have folded, add a piece for the inside, and I've created my entire cube right here. With this, there are some settings that we can have for these bends that are down here. And what's actually going to happen here is these settings are quite important. However, they're not the focus of this video. There's some commands that specifically look at them. So we're setting up the commands currently as we create the piece. We can actually edit those and do that in different ways. And I think it makes a little bit more sense for those pieces to be talked about in a different video. So know that they're there. You'll see the symbols again, and you'll know what they mean. With that, if we scroll up to the top and we go ahead and accept this as our cube, you can see that it is now a sheet metal piece. There is a hollow inside. You can kind of see inside. And there is a gap in those areas that said gap and not in the other areas. And why this is super helpful is because for sheet metal pieces, we want to know what the flat pattern looks like. So I went in and I unsuppressed the flat pattern that was automatically generated when I created my piece as a sheet metal piece. And this is important because when we actually create our drawings and everything for our sheet metal pieces, we really do want to have some form of flat pattern, whether that is so that we can dimension and add dimensions and other things to it, or so we can send this to the water jet to get cut out like this, because this is the piece and this is the shape that's going to get water jet and cut out. You're not going to be cutting out the entire cube as it is. You need to have some idea of how it unfolds so that you can then go back and add the folds sometime later. And that's really the whole reason behind why we use the sheet metal components. With that, what you'll notice is this face right here. That was that original face that I selected that everything else pulled out from. And I can actually see that when I go back and I create my overall piece. So I look at my original box. You're seeing that this face right here that's got that blue border, that is this face that I've selected right up top here. That face never moved as I moved from my flat pattern to not my flat pattern. And so that is where everything is coming from. All of the other pieces are extensions and folds from that. And with that, even with that same piece, I can actually create a different cube using all the same sides by just changing how I have things folded. So I've got everything going off to the side now, and I add a couple other angles. So originally, if you recall this entire face, this is my main face. All of these lines were originally blue. Everything was folding out from this face. Now the only line that's still blue is this line right here. So everything is folding out from this, but is all folding out through this line. So there's other folds coming off of this, such as this guy up here, which wasn't blue before. This guy might have been, I don't remember exactly how it was set up, but that is what we're showing you there. So if I go in and I complete this convert solid just like I did before, I end up with a different flat pattern because the folds come out in different ways. And I can suppress that flat pattern and see it as my cube once again. And we're seeing that things look a little bit differently because I think that I know that before this piece was a bend, kind of like this is a bend. You kind of see this is physically solid versus this is a gap. And this guy was a gap. So kind of like how this looks like now. So drew a little smiley face. Anyways, continuing on. So with this, we have the ability to actually do this with much more complicated pieces. I'm going to make something, it's kind of like a little vent piece that's expanding, just to show you what shapes we might be able to use. And really, you can get as complex as you want to. You just have to be careful that things are actually going to turn into what you want. So in this case, I've created a vent that's expanding, and this is going to cause a couple of issues for me. So when I go in, I want my vent, I'm going to go ahead and set this top face to be my main piece. I'm actually not going to select this face at all, nor am I going to select the face that's on the other side here that I'm not seeing, because if this is like an air conditioning system that is now opening up, what you're going to see, opening up meaning widening here, what you're going to see is there's going to be air flowing through here. So I don't actually want anything on this face. And what I can actually do is make it such that there is nothing on that face. So I'll select my main face and I'll start adding my edges. And so far everything's going great. And then I add this guy. And everything went from being yellow a second ago. I'll do it with the video. Yellow, not yellow. Yellow, not yellow. And that yellow is our preview. Our preview all of a sudden disappeared. So that is pointing out to us that SolidWorks is like, hey, we can't do this anymore. Something's wrong. You selected something that doesn't make sense to it. And in this case, what's not making sense to SolidWorks is that you have a bunch of edge issues that aren't resolvable for them. What we'll see in a second is what SolidWorks really cares about is physically what's happening right on these lines. Does what's happening right on all of these lines make sense? Am I going to have contradictions? Am I going to have pieces that are overlapping that shouldn't be overlapping, or things like that? You can actually get this guy to work out even without having this face here. So the obvious way is to have this face and everything comes out from it. But you can sometimes get SolidWorks tricked into letting us make something like this. But what happens is the flat pattern doesn't work. So continuing on with this, I go to select. It's like, no, you can't do that. Well, let's go ahead and try changing a couple things. So we can see it, let's go ahead and flip the direction. So my vent is now getting skinnier. Can I make it now? So I'm going to convert to sheet metal. I can click through everything, and it's actually going to let me make it. I'm going to go ahead and speed through all of this. So I, again, have not selected. This face is completely unselected, and this back face, you can kind of see in there, is not selected. Those are both brown, or brown-gray. And with that, you see that I actually have a hole straight through. But you also see that it completely made it for me. That is because this guy actually works, and I'm going to actually use the flat pattern of this guy to show why the other one doesn't work. So looking at this guy, what's happening here is, if you recall before, so now I have the angle. I used extrude, could be a loft, whatever. I had a draft in it such that it came in at an angle. Before, I actually had this set up such that it went out at an angle. So I'm going to overdo that angle a little bit here. So if this guy goes out at an angle, and this guy also goes out at an angle, all of a sudden I have, this has got to all be used for this piece, and I'll go ahead and hatch it in this direction. And then for this piece, it's going to, ooh, that is a terrible line. For this piece, it's going to need all of this. And it's going to be hatched like so. And you see that we have an area here that is used by both hatchings. So this guy is being used, I'm going to fill it in. This guy somehow needs to fold as part of this piece over here and as part of this piece over here. So that is not something that is actually going to be doable. That being said, SolidWorks might have let us do it if we got a little bit luckier. But when you got into the flat pattern, things are going to be overlapping. And I'll show you how we can kind of trick SolidWorks in a second here. But that's what's going on. That's why we couldn't create it with those pieces. So make sure if you're making those fancy parts, if you're making them in these ways, make sure that it's actually going to end up being possible. So with this, what I'm going to do in order to trick it, I'm going to add a little bit more detail that is going to create something that SolidWorks is very good at messing up. If I can actually select the right things here, it'd go a lot faster. But I delete everything such that I just have my extrudes, and I'm going to add an extra extrude on this surface right here. And we know how to do all of that, so we'll skip through there. And I have my new body. With this, I'm going to convert this to sheet metal, and I'm going to select all my sides except that. And, well, I should probably go back. So I've got everything selected. I've got all of my bends such that I finish this piece, no problem, with the exception of this piece on top. I never selected it. And because of that, I have that hole. And that hole is basically just adding a hole into my existing pattern because there's nothing selected there. So that is SolidWorks' interpretation of what it thought I wanted. So now let me go ahead and change this. And what I'm going to do is I'm going to select the edges and create this part up top here. It's going to be a series of bends. It didn't like that one. Some corner issue going on there. No problem. We'll select this side here and we'll have it fold in from there. That's got to do with angles and radiuses going on that couldn't be resolved before. So now it thinks it can resolve everything. It's going to be like, great, you've created a SolidWorks part. And honestly, if I just stop and stare at this part, it looks very good. This looks very doable. Unfortunately, this is not doable as all one piece, because if I open my flat pattern, ruh-roh, this guy's not going to work, because this should be a hole, And then I need a whole piece that is this Tetris shape right here that is going to have to fold up in order to create this. And if this Tetris piece is folding up in order to create it, I have a hole this big in my sheet metal that I'm cutting out to create that Tetris piece. So I've got overlapping pieces here that SolidWorks is just not able to resolve. So there are opportunities to create something that can't actually be created in real life. So make sure you double check your flat pattern. There's nothing funky like this going on in your overall part. That is probably the most common mistake that we're going to see. Things like this where it's just this little notch here that looks perfectly reasonable. It's just not something that can actually be made in real life. And SolidWorks, well, SolidWorks isn't always real life. We got lots of opportunities to add different things, different assemblies that you'd actually have to have 3 elbows if you actually wanted to tighten down and fasten. SolidWorks doesn't care about that as long as the physical parts can be made and fit in those locations. It doesn't notice really anything else. So something to be careful about, but that is our convert to sheet metal command, one of the 2 big ways to start a sheet metal part. See you next time.